Hello students, in today's class let us revise the third chapter, trigonometric functions. So to start with, first we have learned the measure of angle measure. Angle can be measured in two types, unit of measurement of angle. One is degree, other one is radian. Degree is one complete revolution, we will denote it by 360 degree. 1 by 360th of revolution, we will call it as 1 degree. 1 degree is 60 minutes and 1 minute is 60 seconds. And we know this is a complete angle and we will measure it in an anti-clockwise direction, right? And if we measure in clockwise direction, it is negative of that angle. Then we have seen radian measure. Radian measure is the angle subtended by an arc of length 1 unit in a unit circle. Unit circle means radius is 1 at the center, right? Then the measure is said to be 1 radian. 1 radian. One complete revolution is 2 pi radian. One complete revolution is 2 pi radian. The relation between theta, L and R. Theta is the angle in radian. L is the arc length. This is what the arc length, right? And R is the radius of the circle. R is the radius of the circle. Theta is L by R or L is R theta. Next we have seen what is the relation between degree and the radian. 2 pi radian is 360 degree or pi radian equal to 180 degree. Using this only we have solved problems, right? And we know 2 pi is 360, pi is 180. So what will be 30 degree? 30 degree can be written as pi by 6 because 180 divided by 6 is 30. Pi is 180. Right, these things we are already familiar, right? 45 is pi by 4, 60 is pi by 3, 90 is pi by 2, 180 is pi, 270 is 3 pi by 2, 360 is 2 pi. Now how we will find the degree measure when the radian measure is given? Radian measure is equal to pi by 180 into degree measure. If we want to find a degree measure will be 180 by cross multiplying 180 by pi into radian measure, right? Radian measure is equal to pi by 180 into degree. Remember, radian is equal to pi, radian equal to pi. Remember in that way. Radian we will denote it in terms of pi. So radian is equal to pi by 180 into degree measure. If you remember one, the other thing you can automatically write. So based on this only we have solved the first exercise. So we have learned the relation between degree and the radian measure. Radian measure is pi by 180 into degree measure, right? And there is no symbol for radian. Degree we will denote it by this small circle, right? But for radian there is no specific symbol. Then we have solved a few problems based on this. 25 degree, they asked you to find the radian measure. Radian measure is equal to pi by 180 into degree measure. So directly you can substitute, cancel, and we can give the answers in terms of pi. Okay. Suppose if the question is like this, 47 degree 30 minutes, you have to convert fully in terms of degree, then only you have to substitute. How we will convert it into degree? We know 1 degree is 60 minutes. So 1 minute is equal to 1 by 60 degree. So you have to divide it by 60. 30 divided by 60 degree, which is half. So minus 47 and a half degree. Like this you have to proceed, right? Then if we have if you end up with 315 divided by 8 degree, if you get like this, you have to divide. If you divide 315 by 8, we got 39 and 3 as our remainder, right? So it can be written as 39 3 by 8 degree, which is nothing but 39 degree plus 3 by 8 degree. Now how you will convert it into minutes into 60, because 1 degree is 60 minutes, so you have to multiply it by 60. Then cancel out, we got 45 divided by 2. Again this is 22 and a half minute. So it can be written as 22 minute plus a half minute. Again half, how will you convert it into seconds? You have to multiply it by 60 again. So 39 degree, 22 minute, 30 seconds. This is how you have to give your answer. Just like that, you should not leave it, right? So hope you people recalled how to convert degree measure into radian measure, right? Now let us move on to the next topic now. Under the same topic, we have also solved a few statement problems like this, finding theta, L and R. Any one of these three values will be asked to find out. So you have to remember theta is L by R. So if the length of the arc and the radius of the circle is given, you can find out what is theta, radius and the length. You may get a statement problem like this. In a circle of dia 40 cm, the length of the chord is 20. Find the length of the minor arc. Find the degree measure of an angle subtended to the center of a circle of radius and arc length. This is a direct question. Radius and arc length is given. They asked you to find the degree measure, right? So you have to use the relation between theta, L and R, and then you have to solve the problems, right? Now next we are going to see trigonometric functions. Next we have defined trigonometric functions. Till 10th standard we have learnt trigonometric functions only for a right triangle. Right now in this class we have extended beyond it, and we have defined it. First we have introduced by considering a unit circle, and we have considered a right triangle which makes an angle x with the x-axis. Then we told cos x is a by taking the point P on the circumference of the circle as a comma b. Cos x is going to be a. We have defined the trigonometric ratios for this triangle, right? It's a unit circle, so the radius is going to be 1. So cos x will be a and sin x is b. So from this we told cos square x plus sin square x is equal to 1. This is a known identity. We have derived it using the unit circle what we have considered. So first we have learnt the identity, then we have seen what are the quadrant angles. Integral multiples of pi by 2 are called as quadrant angles. Integral multiple of pi by 2 are called as quadrant angles. One complete revolution is 2 pi radian, right? 2 pi radian, then pi by 2, pi, 3 pi by 2. This is pi by 2. Then this is pi, then 3 pi by 2, then this is 2 pi. This is complete revolution, right? Pi by 2, pi, 3 pi by 2, 2 pi. These are all called quadrant angles. These are all integral multiples of pi by 2. Then we have seen the cos and sin values for these quadrant angles, integral multiples of 2 pi. We have seen cos 0 is 1. How it has become cos 0, 1? Using this unit circle. Again, if the angle made is 0, it is going to be 1. When it goes to cos pi by 2, it is going to be 0 because cos x is a, right? Cos x is a. So cos 0 is 1, cos pi by 2 is 0, cos pi is going to be minus 1, and cos 3 pi by 2 is 0 again, and when it goes to 2 pi, again it is going to be 1, right? So it repeats after 2 pi. Right? What will happen to sine? Sine 0 is going to be 0, b value, y coordinate. Sine 0 is 0, sine pi by 2 is 1, sine pi is 0, sine 3 pi by 2 is minus 1, again sine 2 pi is going to be 0. So based on these values, we have given a general conclusion. Any integral multiple of 2 pi, the values of sine and cosine functions do not change. So with any integral multiple of 2 pi, again it repeats. So sin 2n pi plus x is equal to sin x. Similarly, cos 2n pi plus x is cos x for any n belongs to z. This is again an important result you have to remember. Sin 2n pi plus x is sin x. Cos 2n pi plus x is cos x for any n belongs to z. Alright. Also sin x is 0 if x is equal to 0 plus or minus 5 plus or minus 2 pi etc. But cos x is 0 for x is equal to plus or minus pi by 2 plus or minus 3 pi by 2 etc. Right. So in general how we will write sin x is 0 for x is equal to n pi, because sin value is becoming 0 for x is equal to 0, pi, 2 pi, likewise it goes on. So we can write, but cos value becomes 0 only for pi by 2, 3 pi by 2 etc. So in general you can give sin x is 0 for x equal to n pi, where cos x is 0 for x equal to 2n plus 1 pi by 2, where odd integral multiple of pi by 2, where n belongs to z, and in general you can say Only for odd integral or multiple of pi by 2, cos value becomes 0, because 2n plus 1 is nothing but odd integral multiple of pi by 2. Okay, so for any integral multiple of 2 pi, sine and cosine function will not change, do not change, and a sine function will become 0 for any integral multiple of pi, and cos function will become 0 for only odd integral multiple of pi by 2. So these are the two results we have learnt first. Then using this we have defined other trigonometric ratios. Cosec x is reciprocal of sin x, secant is reciprocal of cos. All these things we know already. But while defining we have given a constraint, because we know sine function will become 0 under any integral multiple of pi. So we have mentioned that x should not be equal to n pi, where n belongs to z. Similarly, cos function we will know it will become 0 on any odd integral multiple of pi by 2. So we will mention x will not be equal to 2n plus 1 pi by 2. So these are all general things. And we have derived the other two identities, well-known identities, which we have learnt in our earlier classes using this. So what are the three identities? Sin square x plus cos square x equal to 1. 1 plus tan square x is secant square x, 1 plus cot square x is cosecant square x. So far what are all the important things we have learnt under trigonometric functions? We have seen the sine and the cosine values of quadrant angles, integral multiples of pi by 2. Then we have seen under any integral multiple of pi, the sine and the cosine functions will not change. Or any integral multiple of 2 pi. Any integral multiple of 2 pi, the cos and the cosine function do not change. And then we have seen under any integral multiple of pi, sine function will become 0. Under odd integral multiple of pi by 2, cosine function will become 0. And then we have seen the three identities. Right? Then we have tabulated all the values. These are all the known values which we have seen right now, and these things we know already. The standard angle 0 to 90 degree, pi by 2 we have mentioned in terms of radian measure. That's it. Then sign of trigonometric functions, we have derived the sign of trigonometric functions using the unit circle, which is nothing but cos of minus x is cos x, sine of minus x is minus sin x. Okay, cos of minus x is cos x, sine of minus x is minus sin x. This negative will affect only the sine function. Even I gave you a hint to remember this. Yes for snake. Snake is so poisonous. So minus sine of minus x will get reflected here, minus sin x. Remember in that way. These are all small hints to remember things. Or if you have a better gimmicks to remember, keep that in your mind and learn so that you won't forget, right? Cos of minus x is cos x. Cos is a good human. Whereas sine of minus x, sine S for snake, which is very poisonous, so it will affect. So you will get minus sin x, remember. Then we have seen the sign of the other trigonometric functions as well. Again, I told you how to remember the signs of the other trigonometric functions. All silver teacups. Here all trigonometric functions are positive. Here only sine and its reciprocal is positive. Here only tan and its reciprocal is positive. Here only cos and its reciprocal is positive. Remaining other things are negative. All silver teacups. We know first quadrant, second quadrant, third quadrant and fourth quadrant. Yes, so all silver teacups. All sine and its reciprocal, tan and its reciprocal, cos and its reciprocal. Only all these will be positive, remaining functions will be negative. Right? Then we have seen the domain and the range of trigonometric functions. For sine and the cosine, domain is the entire real number, but the range, if you see, the values will lie in between -1 to 1, closed interval. Right? Because we have seen after 2 pi, the values are going to repeat. They do not change, right? So it is going to be -1 to 1. For cosec, the entire real number system except for n pi, because we know the denominator will become 0 for n pi, therefore n pi alone is omitted. Similarly for secant, n pi plus 1 pi by 2 is omitted because we know under that the cos function will become 0. right? So what will be the range? Range is y greater than or equal to 1 or y less than or equal to minus 1, because it will not be equal to 0. We cannot have the answer as 0. So 0 alone is omitted there under range. Similarly for secant. Then for tan, again the same way. For tan, sine by cos. Cos is going to come under denominator, so we have omitted 2n plus 1 pi by 2. For cot, sine will be in the denominator, so n pi is omitted. Range is going to be entire real number system, right? Hope you people are recalling what we have learnt under trigonometric functions. Then we have seen how to find the values of other trigonometric functions. They have given you cos x is minus 1 by 2, x lies in third quadrant. This is again an important question, type of question in this chapter. Cos x is minus 1 by 2 and they are told you x lies in the third quadrant. So immediately draw your quadrants, all silver teacups. When x lies in the third quadrant, only tan and its reciprocal is positive. Remaining things will be negative. So identify, keep it in your mind. Right? When you know cos x, immediately you can give what is your secant x. Secant x is 2 by 1 minus 2. Right? So we got cos x, secant x now. Now using cos x, you can find what is your sin x using the identity cos square x plus sin square x equal to 1. And we got sin x as plus or minus root 3 by 2. So here for assigning the sign of sine function, you have to use this. X lies in the third quadrant, therefore tan and its reciprocal alone positive. Therefore sine will become negative, minus root 3 by 2. After getting the values for cos, secant and sine, you can find the other ratios. Cosec is going to be 1 by sine, so you can reciprocate it. Tan is going to be sine divided by cos and cot is reciprocal of tan. Okay, so when a question is given like this, first see where x lies, in which quadrant it lies. Accordingly, you have to assign the sign for the trigonometric functions, right? The another type of question is find the values of the trigonometric function sine 765 degree. For solving this kind of problem, you have to remember that the value of sine and cosine will repeat after an interval of 2 pi or 360. Whereas tan will repeat after an interval of pi. This we have seen already. So sine and cosine function values will not change after any integral multiple of 2 pi. Tan function pi, right? So if an angle is given, try to express it as a product of integral multiple of 2 pi. So 765 can be written as 2 times 360 plus 45. 2 times 360 plus 45. You have to divide 765 by 360, right? When you have a degree measure, you divide it by 360. And when the angle is positive, you divide it by 360 and write it. When you divide 2 times 360 plus remainder, you will get 45. So it can be written as 2 times 360 plus 45. And since it is an integral multiple of 2 pi, this is nothing but sine 45. Sine 45 is 1 by root 2. Like this you can find the angle. But when it comes to a negative angle, what will you do? You have to take that number 1410, if it is under degree measure, divided by 360. You got some quotient, right? The next number of the quotient you have to take. So minus 1410 plus 3 here we got. So 4 times 360 you should write. Okay, multiply and find out the answer. If you subtract, you will get one of the standard angle. Then you can give your answer. Hope you can make out the difference between the positive angle and the negative angle. If it is going to be the positive angle, directly you divide and express it as a multiple of 360 plus the remainder. When you get a negative angle, keep the angle as such. Take this angle and divide it by 360 plus you write it as the next number of the quotient. How it is possible? The same rule, because we know the sine and the cosine function will repeat after integral multiple of 2 pi. So here we have expressed it as a sum of the integral multiple of 2 pi only. The given angle we have expressed this as the integral multiple of 2 pi. Plus we have added here. Here we have splitted the given angle into 2. Okay, here with the given question, we have added some integral multiple of 2 pi because anyhow it's not going to make any change with the question. right? The same way, if it is going to be a radian measure, what will you do? If it is going to be a negative radian measure, the same way, 15 divided by 4, you divide 15 by 4, the quotient is 3. So minus 15 pi by 5, 4, plus the next number of the quotient is 4. So you add 4 pi. Now you take LCM and simplify, you will get a standard angle, then you can give your answer. This is what the procedure, right? So we have seen two types of problems now. One is if any one of the ratio will be given and they will ask you to find the remaining trigonometric ratios based on in which quadrant it lies, and using the trigonometric identities you can give the remaining ratios. The other type is they will give one angle and they ask you to find its trigonometric values, trigonometric ratios. So here you have to use this note. What is it? The sine and the cosine function will repeat after an integral multiple of 2 pi, and tan function will repeat after integral multiple of pi, right? That's why we have used here 4 pi, and here we have, when it is positive you can split like this, when it is negative you have to express like this, right? Let us move on to the next topic now. Here comes our favorite topic, trigonometric identities, trigonometric functions of sum and difference of two angles. All these identity you have to by heart and remember. These two we have already seen. Sine of minus x is minus x snake. Cos of minus x is cos x. Then these four are also familiar to us. Cos x plus y is cos x cos y minus sin x sin y. Cos x minus y is cos x cos y plus sin x sin y. Sin x plus y is sin x cos y plus cos x sin y. Whereas sin x minus y is sin x cos y minus cos x sin y. When it comes to cos plus opposite sign. When it comes to sin, the same sign. Cos a cos b, sin a sin b, sin a cos b plus cos a sin b. Then what about these four? We know this complementary angle. 90 minus theta is, this will change, the trigonometric ratio will change, right? Cos pi by 2 minus theta is sin theta. Sin pi by 2 minus theta is cos theta. What will happen to cos pi by 2 plus theta? When it comes to pi by 2, when it comes to 90 degree, the trigonometric ratio will change. But when the sign will change, it depends on the quadrant. Pi by 2 minus x, na, it lies in the first quadrant. First quadrant all are positive. So we got the same sign, plus sign. When it comes to pi by 2 plus x, it moves to the second quadrant. In second quadrant, sign and its reciprocal is positive. So cos has become negative. Sign has become positive, right? So you have to think and give your answers like this. When it comes to pi by 2 plus or minus theta, the trigonometric function will reverse. Cos will become sin, sin will become cos. Sin you have to think and give. Okay. When it comes to pi plus theta or 2 pi plus theta, the same trigonometric ratio we will get. Only the sign you have to think and give. When it comes to pi minus theta, pi is this, pi minus theta, na, again it will lie in the second quadrant only. In the second quadrant only sign and its reciprocal is positive. Remaining things you have to give negative sign. Pi plus theta means it will move on to the third quadrant. In the third quadrant, tan and its reciprocal is positive. Remaining will become negative. When it comes to 2 pi minus theta, 2 pi is this, 2 pi minus theta means again it will lie in the fourth quadrant. There only cos and its reciprocal is positive. Remaining you have to give negative. Right? So remember, when it comes to pi by 2 plus or minus theta, the trigonometric function will change. For pi and 2 pi, the trigonometric function will not change. Only the sign you have to allot. Then tan x plus y is tan x plus tan y divided by 1 minus tan x tan y. Similarly for tan x minus y, all these identities you have to by heart. Cot x plus y, cot x minus y. Then it is cos 2x is cos square x minus sin square x, or 2 cos square x minus 1, 1 minus 2 sin square x. This is in terms of tan. 1 minus tan square x divided by 1 plus tan square x. Similarly, sin 2x is 2 sin x cos x. In terms of tan, 2 tan x divided by 1 plus tan square x. Tan 2x is 2 tan x divided by 1 minus tan square x. This formula is you can remember by hearting cos 2x and sin 2x in terms of tan. Tan is sin by cos. Sin or the numerator 2 tan x. Cos or the numerator 1 minus tan square x. So it is 2 tan x divided by 1 minus tan square x. Right. Then is 3x. Sin 3x is 3 sin x minus 4 sin cube x. Cos 3x is 4 cos cube x minus 3 cos x. These are all the identity you have to remember. Then repeatedly used identities are these four: sum and the difference of the angles. What is it? Sin x plus sin y is 2 sin x plus y divided by 2 cos x minus y divided by 2. For this I told you how you can remember. S plus S, S minus S, C plus C, C minus C, SC, CS, CC, SS minus. You can remember in this way. If you are unable to recall what it is directly, you can write this in the corner of your answer sheet and you can check out your formula and then you can do it. When you have x and y here, you have to add and divide it by 2. Subtract and divide it by 2 for the second thing. First thing you have to add and divide by 2. For the second thing you have to subtract and divide by 2, and 2 should be multiplied. Right? All these identities you have to by heart. Then we have solved problems, simple problems based on this. When you get the standard angle directly, you can substitute the values and you can prove it. Pi by 6, pi by 3, pi by 4 are standard angles. But when you get angle like the 7 pi by 6, you have to split it, because we know, right, what we know. We can write it pi plus theta, pi minus theta, like that. We have learnt under formula. So what will happen? You have to think according to the sign, according to the quadrant where it lies, you have to assign the sign. 7 pi by 6 can be written as pi plus pi by 6. When it comes to pi plus theta, it will lie in the third quadrant. In the third quadrant, all silver, T, tan and its reciprocal is positive, so cosec will become negative. Right? Accordingly, you have to assign the sign and solve the problems like this. Right, here also 5 pi by 6 can be written as pi minus pi by 6. And we know when we express it in terms of pi, the trigonometric ratio will remain same. When we express it in terms of pi by 2 only, the trigonometric ratio will get reversed. Right? And this kind of problems again can be written as sin 45 plus 30, and you can use sin x plus y identity. So these are all the problems where we can solve using the identities. Right? And this kind of problems again, cos pi by 4 minus x, cos pi by... So the problems using the last set of identity, what I told, s plus s, s minus s, c plus c, c minus c, only repeatedly we will come across. Here it is like, and this is cos x minus y identity, cos a, cos b minus sin a, sin b. Right? So this is nothing but cos a minus b. So unless and until you are thorough with the identities, you cannot solve these kind of problems. On looking at the identity, you should able to recognize what identity it is. Right? If you see this example again, what is this example? Cos 3 pi by 2 plus x, cos 2 pi plus x into cot 3 pi by 2 minus x plus cot 2 pi plus x. And we know when we have integral multiple of pi by 2, the trigonometric ratio will change. So cos x has become sin x, but this is 3 pi by 2 plus x. 3 pi by 2 is this plus x. Right? Cos and its reciprocal is positive, so it has become plus sin x. 2 pi plus x, when it becomes an integral multiple of pi, the trigonometric ratio will remain same. So cos 2 pi plus x is become cos only, but 2 pi plus x means 2 pi is this full angle. When it comes to 2 pi plus x, it will go to the first quadrant. First quadrant all are positive, so it is positive. So in this way you have to think and assign the trigonometric function and the sign, and then you have to slowly solve your problem. Right? Problems of this kind. First, they asked you to prove. First, we have used a square minus b square identity, a plus b into a minus b. Now we have used one among this. S plus s means 2sc. 6x plus 4x divided by 2, 6x minus 4x divided by 2. Similarly for this. So problems of this kind only repeatedly will be asked. Then slowly you have to simplify. We got sin 5x cos x cos 5x sin x. So it can be written as 2 sin 5x cos 5x into 2 cos x sin x. So 2 sin x cos x is sin 2x. So you have to know all the identities. That's why I am telling you, only if you have a thorough or good knowledge with the identities, you can solve the problems easily. On looking at it, you should recognize, and immediately it should strike your mind, this resembles this identity, so use that and your mind should tell. In that way you have to be thorough with the identities, then only you can solve. And when you have a question like this, you can choose, see here it is 2 sin A identity, and these two you can take s plus s, you can apply and then you can solve it. Hope you people are recalling the things what we have learnt. These are all the things we have learnt in the beginning of the year, right? So kindly recall. Repeatedly we will use this set of identities only, and then we will solve the problems. Again, only if you practice you will get all these things. Next we have seen another important concept called trigonometric equations. For this we have two types of, for a trigonometric equation we can give two types of solutions. One is principal solution, another one is general solution. Principal solution means the solution of the equation which is expressed in terms of 0 to 2 pi is called a principal solution. General solution is involving integer n. Okay, generally we will express this is what the solution will be, and we know sine and cos will repeat after interval of 2 pi and tan will repeat after an interval of pi, right? Now let us see how to find the principal solution of the equation sin x equal to root 3 by 2. So how to find this? We know that when x sine value will become root 3 by 2 under pi by 3. So sin x is root 3 by 2, which is nothing but sin pi by 3 is root 3 by 2, right? And here we can see that sine value is positive. Where sine value will be positive? Under 4 quadrant, all silver tea cups. So in the first and the second quadrant, sine value will be positive. So the sine solution, the solution of this equation, which means the value of x can lie in the first quadrant or in the second quadrant, right? If it lies in the first quadrant, the angle is just pi by 3. So x can take up the value pi by 3. If it lies in the second quadrant, what it will be? It will be expressed as pi minus pi by 3. You have to use only pi. You should not use it as pi by 2 plus theta, because when it comes to integral multiple of pi by 2, the trigonometric ratio will get reversed. Sine will become cos, cos will become sine. Hope you remember. Only when we express it in integral multiples of pi, the sine value will be sine, cos will be cos. Right? So to express the principal solution, when it lies in the first quadrant, we will give the angle as such. When it lies in the second quadrant, we will write it as pi minus theta. When it lies in the third quadrant, we will give pi plus theta. And when it lies in the fourth quadrant, we will give 2 pi minus theta. Right? Here it is pi plus theta. Here it is 2 pi minus theta. Here it is just theta, and this is pi minus theta, right? So here x is root 3 by 2, so this is going to be pi minus pi by 3, which is nothing but, if you take LCM, it is 2 pi by 3. Therefore the principal solutions are pi by 3 and 2 pi by 3. We will see one more example. Tan x is minus 1 by root 3. We know tan 30 is 1 by root 3, but here it is negative. Where tan will be negative? In the second and the fourth quadrant. If it lies in the second quadrant, theta we will express it as pi minus theta. So pi minus pi by 6. When it lies in the fourth quadrant, it will be expressed as 2 pi minus theta. So 2 pi minus pi by 6. So these are the two principal solutions of the given equation. So if you take LCM and simplify, we got 5 pi by 6 and 11 pi by 6. Hope you got it. Now let us see how to give the general solutions. You have to remember the general solutions. Sin x equal to sin y means x is equal to n pi plus minus 1 the whole power n into y. Cos x equal to cos y means x is equal to 2n pi plus or minus y. Tan x equal to tan y means n pi plus y. Okay. Sin x plus sin y is n pi plus minus 1 the whole power n into y. For cos it is 2n pi plus or minus y. For tan it is n pi plus y. You have to remember these general solutions. So now let us see one example how to find the principal and the general solution of the given equation. Now the equation is tan x equal to root 3. So as usual, let us find the principal solution. We know under tan 60 is root 3, so it is pi by 3, but it is positive. Therefore, theta should lie in the first or the third quadrant. If it lies in the first quadrant, theta is going to be pi by 3. If it lies in the third quadrant, it can be expressed as pi plus theta. So it is going to be pi plus pi by 3. So if we simplify, we got 4 pi by 3. So the principal solutions are pi by 3 and 4 pi by 3. Now how to find the general solution? Now it is of the form tan x equal to root 3. So you can take any one of the principal solution. So tan x can be written as tan pi by 3 or tan 4 pi by 3. Any one of the principal solution you can choose. Now it is of the form tan x equal to tan y. Then what is the solution? X is equal to n pi plus y. What is your y? Pi by 3. So this is what your general solution. So this how only you have to give the general solution of the given trigonometric equation, right? See this example. If you have sine, cos or tan, directly you will relate in this general solution. If it is of cosec or secant or cot, what will you do? You know how to find the principal solution in the same way. When it is going to be 2, cosec 30 is 2. Right, but it is negative, so the theta can lie in between in the third or the fourth quadrant. Cosec means it's a reciprocal of sine, right? All silver teacups. So in the third and the fourth quadrant only it will be negative. So accordingly we can choose. If it lies in the third quadrant, it is pi plus theta, fourth quadrant 2 pi minus theta. So we have expressed and got a principal solution. Now how we will give the general solution? We have to rewrite it in terms of sine. Cosec is minus 2. So cosec x is cosec 7 pi by 6. So which is nothing but 1 by sine x is equal to 1 by sine 7 pi by 6. Which is nothing but sine x equal to sine 7 pi by 6. Now it is of the form sin x equal to sin y. Then what is the solution? N pi plus minus 1 the whole power n into y. Y is nothing but 7 pi by 6. Like this you have to give your general solution. Right? Hope you people have recalled the things. See, so far we had a simple trigonometric equation. Now if you get a question like this, cos 4x equal to cos 2x. Find the general solution. So first we have to solve it. Here x is 4x, y is 2x. So you have to substitute x as 4x and y as 2x and then you have to simplify. Okay, or else this is a standard way you can perform for all types of problems. So you can go with this method. Cos 4x equal to cos 2x. So if you bring it to the other side, it will become minus cos 2x is equal to 0. Now it is of the form c minus c. So which is minus 2sc. Right, now we got sin 3x into sin x equal to 0, which means sin 3x is equal to 0, sin x equal to 0. Now you have to simplify this. When sin value will become 0 under integral multiple of pi. So 3x is nothing but n pi. Okay, so x is n pi by 3 where n belongs to z. Here also x will become 0. Sin value will become 0 under integral multiple of n pi. So x is equal to n pi. Right? This how only you have to solve problems of this kind. Now see, let us see another example. You have a question like this. They asked you to find the general solution. Again here we have to go with those set of identities. So we have simplified. We got cos 2x as common. 2 cos x minus 1 equal to 0. So cos 2x equal to 0. 2 cos x minus 1 equal to 0. So first let us simplify this. Cos value when it becomes 0 under odd integral multiple of pi by 2. So it is 2n plus 1 into pi by 2. So x is 2n plus 1 into pi by 4. Right? When you simplify this, 2 cos x minus 1. So 2 cos x is 1. Cos x is 1 by 2. When cos value will become pi 1 by 2, cos pi by 3. Right? So cos x equal to cos y form. So the general solution is 2n pi plus or minus y. Right? 2n pi plus or minus y. So you have to use that general solution here. So the general solution is this one or this. Like this you have to give your conclusion. See, there is again another kind. Here we got directly, but in this problem we got sin x equal to minus half. So minus sin pi x. We don't have a general solution for sin x equal to minus sin y, right? So how to simplify this? When the sin value will become negative? In the third quadrant or the fourth quadrant. If it is in the third quadrant, it will be expressed as pi plus theta. So this can be written as pi plus pi by 6. So if you simplify, we got 7 pi by 6. Now it is of the form sin x equal to sin y. Then you have to give your general solution. Right? So we have seen how to give the principal and the general solution for the given trigonometric equation. Hope you people are following. Then in miscellaneous exercise, we have seen many problems using those set of identities which I have told already, s plus s, s minus s, etc. Right? So if you have a question of this kind, sin 3x plus sin 2x minus sin x, you can use any those identities repeatedly and then you can solve it. So these questions only under practice you will get it. Okay. Here they have used sin 2x, they have separated. Here they have used s minus s. So which is nothing but 2cs identity. Again sin 2x identity, 2 sin x cos x. So you have to be thorough with the identities, right? Then another important type of problem which we have seen under this chapter is finding x by 2, angle x by 2. So earlier we have seen how to find the trigonometric ratios, right, for this single angle. Now we are going to see how to find it for the half angle. If tan x is minus 4 by 3 and x is in the second quadrant, you have to find out where x by 2 will lie. Okay. So if x is in the second quadrant means what is the angle measure? Pi by 2 to pi, right? Pi by 2 to pi. This is 0 to pi by 2 and this is pi by 2 to pi and this is pi by pi to 3 pi by 2 and this is 3 pi by 2 to 2 pi. Alright, now it is given x is in the second quadrant. When they ask you to find x by 2, first you have to identify where x by 2 lies. Now x is in the second quadrant, which means pi by 2 less than x less than pi. So you have to divide throughout by 2. So this will become pi by 4 less than x by 2 less than pi by 2. So x by 2 lies in between pi by 4 and pi by 2. Alright. Pi by 4 and pi by 2. Pi by 4 means 45 degree, pi by 2 is 90 degree. So it lies in between 45 and 90, which is nothing but your first quadrant. Or else I'll give you a clue. If x lies in the second quadrant, x by 2 will lie in the first quadrant, a quadrant before. Okay. If x lies in the third quadrant, x by 2 will lie in the second quadrant. If x lies in the fourth quadrant, x by 2 will lie in the third quadrant. Likewise only you will get. But manually if you want to do it like this only, you have to simplify. So make it into a radian measure in which quadrant it lies and divide throughout by 2 and check out where x by 2 lies. So accordingly you have to assign the sign. Okay. Now remaining procedures are same as we have done in finding the single angle, but the formula identity where we are using for single angle, here we have to use it for the half angle. That's it. So here tan x is minus 4 by 3 and x lies in the second quadrant. So we found where x by 2 lies. Now let us use 1 plus tan square theta is equal to secant square theta identity. So we found what is secant square x. So secant x is square root of 25 by 9, which is plus or minus 5 by 3. Alright. Since x lies in the second quadrant, secant x lies in the second quadrant, all silver. Right, only sine and its reciprocal is positive. Secant is the reciprocal of cos, so it will be negative minus 5 by 3. So cos x is minus 3 by 5. Using cos x only, we are going to find out what is cos x by 2. Because we know cos 2a is 1 minus 2 sine square a. Or else we can write 2 cos square a minus 1. You can use any one of these identity according to the data which you know. So cos a is going to be 2 cos square a by 2 minus 1. So cos x can be written as 2 cos square x by 2 minus 1, which is minus 3 by 5. Hope you got it why it is minus here. Because x lies in the second quadrant, that's why it is minus, right? Then if we simplify for cos x by 2, we got square root of 1 by 5. 1 by 5. Now x by 2 lies in the first quadrant, all trigonometric ratios are positive, therefore cos x by 2 will become 1 by root 5. Now using cos x by 2, we can find what is sin x by 2, because we know sin square theta plus cos square theta is 1. Sin square x by 2 plus cos square x by 2 is 1. So if you substitute, we can find what is sin x by 2. Again assign the sign based on the quadrant in which x by 2 lies. Don't blindly assign your sign based on x, okay, because we are finding x by 2. Then you can find what is tan x by 2. Okay, so what we have done, when the quadrant where x lies will be mentioned in the question, as a first step you have to identify where x by 2, in which quadrant x by 2 lies, keep it aside, then solve for this and get the value of cos x or sin x, any one value, then go for cos 2x identity. You can get for x by 2, assign the sign according to the quadrant where x by 2 lies, then find the sin x by 2 and tan x by 2. Let us see one more example. Here cos x is minus 1 by 3 where x lies in the third quadrant. As I told you, if you divide, third quadrant means here pi to 3 pi by 2, right? If you divide throughout by 2, we got pi by 2 and 3 pi by 4. So which means x by 2 lies in the second quadrant. As I told you, you can remember in this way also. Here x lies in the third quadrant, so x by 2 lies in the second quadrant. Here cos x value is directly given, okay, minus 1 by 3. So directly we can use cos x by 2, cos 2a formula. So cos 2a can be written as 2 cos square a minus 1. So cos a is going to be 2 cos square a by 2 minus 1. You can substitute and we have found out what is cos x by 2. So cos x by 2, you have to assign the sign based on the quadrant where x by 2 lies, okay. After finding cos x by 2, we can find sin x by 2 using the identity cos square x plus sin square x equal to 1, and then we can find what is tan x by 2, right. So we reached the end of the chapter. We have recalled all the things what we have learned so far. So first we have learned what is meant by radian and the degree angle measure. Then we have seen the trigonometric functions for the quadrant angles, and two important notes where it will become 0 and where it will not change. Then based on this we have seen problems, and then the sign of the trigonometric functions. We have seen sin of minus x is minus sin x, cos of minus x is cos x. Then what about the sign of the other trigonometric functions? Then the domain and the range of the trigonometric functions, how to find the trigonometric values when one trigonometric function is given. Then we have seen the various trigonometric identities. This is very important part of the chapter, you have to remember. Then based on the identity, we have seen how to solve the problems, right? Then we have seen how to find the solution of the trigonometric equation, how to find the principal solution and general solution. Again we have seen 2-3 methods, 2-3 models under this. Then at last we have seen how to find the values of x by 2 as well, right? Do these problems as homework, and if you have doubts, ask me. Thank you, students.